Welcome back. This is the problem with using a free stuff. The quality is not always there, but we continue from where we stopped. We have 13 students or 13 students that logged in back. So we continue from where we stopped. Every 40 minutes this happens. So we will manage it like that. Once it stopped, then we log back in. So where did we even stop? We are talking about what the third, that is solution to linear equation.
Hello, sir. I say we stop at plotting the graph.
Sorry?
We stop at plotting the graph. The graph you were trying to demonstrate it.
Yeah, that's true.
Linear on a graph.
So like we have this linear equation. For example, we have this 2x minus 3y
3y
equals to
is equals to 7.
7. So the question is, how do we solve this? So I explained to you that the solution to this, we want to find a number for x and y, whereby this equation will hold. I assume that if x equals to 5, right? And y equals to 1.
Equals to 1.
So if we substitute where these variables are, we remove x and put y there, and we remove y and put 1 there. Let me do it in as it is. That is 2 times 5 minus 3 times 1 equals to 7. So this equation must hold. So this will be 10 minus 3 equals to 7. And this equation holds because 10 minus 7, 10 minus 3, it's 7. So the solution to this equation is what? X coordinates, then y coordinates. And we know that x coordinate should be what? 5. And y coordinate should be what? 1. Remember? This. But someone will ask, how did you get this 5 and 1? Because I just bring it up. How do we get it? It's very, very simple. So when you want to find solution, you can take any number. For example, you have this linear equation, the same thing, I'm rewriting it again, 3x minus 3y equals to this. So ask yourself, if x equals to, you can take any number. It could be any number. If x equals to 5, then you solve the equation. So if x equals to 5, what will happen here? We substitute, we remove this x and put 5 there. So it will be what? 2 times 5 minus 3y equals to 7. So 2 times 5 will be how much? 10 minus 3y, not sure, equals to 7. So we could say that you can move the like terms. This 10 will come to the left, the right-hand side of the equation. So it will be what? 7 minus 10. It will minus 3y equals to 7 minus 10, not sure. So this will be minus 3y equals to minus 3. 7 minus 10 is minus 3. Our algebra, I hope we don't forget our signs. So we want to know the value of y.
Divide both sides by minus 3.
Exactly, by minus 3. So we cancel this, we cancel this. Then our y will be what? 1. Because this is minus 3. Divided by minus 3, it will give you 1. So we have y equals to 1, while x equals to 5. But this is not the only solution to this system. Someone can also say, what if x equals to 2? Let's look at that. So that's why the solution to a linear equation, you can have many solutions. but the combination must be correct. So for this one, if x equals to, let's write here, x and y, the combination is what? 5 and 1. But someone could say, what if x equals to 2? Let's look at that. If x equals to 2, let's look at that. So the solution to this linear equation, you can have more than one solution. You can have, we have x and y. Sorry, x and y. So the first one we have is when x equals to 5, y must be equals to 1. But let's ask yourself, if x equals to 2, y must be what? So let's look at that. If x equals to 3, y must be how much? We can equally even say that y equals to, we can start with y, it doesn't matter. So what is important, the combination that you will use must yield this constant. The equation must hold. So let's look at the situation. So the solution to linear equation can be many solutions, but we make sure that the combination that we use should make sure that we should make sure that it holds the equation. So let's assume that I said x equals to 2, but someone could say, what if x equals to 2? So let's look at that. So we have our equation like this, 2x minus 3y equals to 7. So someone could say, what if x equals to 2? What will be the value of y? So we find that. So what we will do, let's just substitute x. We have x here. So we remove it and substitute it with 2. When x equals to 2, because what this is telling you, multiply 2 by x. And since we know 2, x is 2, then we multiply 2 by 2. Then we said minus 3y equals to 7. So this will give us 2 times 2, that is 4, minus 3y. So this will give us 7. So at the end of the day, we'll have minus 3y equals to 7, minus 4, not so. So we will have minus 3y equals to 3. We want to know the value of the variable, and all what we need to do is divide both sides by minus 3. This is what we are interested in, y. So all what we need to do, we divide by minus 3, then minus 3. So here y will be what? Minus 1. So we go back, if x equals to 2, then y will be minus 1. So if you use this, we substitute this, the equation will hold. If x is 5, y is 1. If x is 2, y is minus 1. So these are the solution to this linear equation. So you can take any number, but the combination must be right. So if we have our graph here, we have this is our coordinate system on the plane geometry. So we will have, as usual, we bring x to what? To the horizontal axis and the y to vertical axis. So we have 4 quadrants. This is quadrant 1. Here is quadrant 1. Here is quadrant 2. And here is 3. And here is 4. So we will look at here, y and x in this quadrant, they are all positive. So here we have x and y, and their coordinates are what? All of them are positive. I should not even go further on this because we have a section whereby we will be talking about graphs of linear equations. So all what I'm trying to do here, we have, if x is 5, we know that y is what? 1. If x is 2, we know that y is what? Minus 1. We can go on. We can even go on and, use 5, 2, 1, 8, 10, 20, any numbers. So the solution here we have, so what I'm trying to put across is that when you see a linear equation, the solution, it can have many solutions. And that solution is the coordinates of X and Y. And that combination must be right for the equation to hold. So we have here, let's say X is, this is 1, this is 2, this is 3, this is 4, and this is 5. We have X, it has the negative, where X is negative, the axis. This is -2, this is -3. Sorry, I'm very horrible when it comes to drawing graph. So we have 1, we have 2, we have 3, we have 4. So we have -1 here, -2, -3. So this combination 5, what they are saying, X is 5, then Y is 1. So we have X here as X, the 5 is here, and Y is here. So they will meet somewhere around here. So this is the point. This is a solution to the linear equation. So when X is 2, Y is what? -1. So they will meet around here. So this is also a solution. So we can call this even point A and point B. Like A is a solution to linear equation, and point B is also a solution. So when we keep doing this, yes?
When X is 2, Y is -1. On your graph, it says when X is 1, Y is -1.
No. When X, okay, this should be here.
Yes, it should be there.
Okay, this should be here. So we have this. So at the end of the day, like each point, because if we looked at this, nothing but if we look at this equation, linear equation, it's nothing but a straight line. So when you have an equation whereby the two variables like X and Y, the highest power there is 1, if you graph it, you will have nothing but a straight line. So at the end of the day, we have this point. Let's make this clear. So we have this, that is the second, the B point. We have Bx equals to 2, which is here. And Y equals to -1. So where they intersect, that will be our point, and that will be the solution for that linear equation. So if we go on, after we will do things like intercepts, Y-intercept and X-intercept, maybe we'll have nothing but a straight line like this. So it goes, so it will cut, where it cuts X here, and where it cut Y here, we call here as what? Y-intercept. So we will calculate, we will look at how do we calculate Y-intercept and X-intercept. So where it cuts X-axis, we call it X-intercept. So we can also conclude the linear equation when they are on a geometry or coordinate system, the line is always straight. But if we start to things like non-linear equation, especially quadratic, you will see things like this. But for now, let's forget them. So linear equation, the graphs is always a straight line. So every point here on this straight line, every point, here is A, here is B. So every point on this straight line is a solution to a linear equation. So this is how you solve linear equation. To repeat again, all what you need to do, you can take any number, think of any number and say that let X be that. And if you said that X, let X be that, then you ask yourself, what is Y? So if you have those 2 points, then that will be the solution to the linear equation as we did it in point A and point B. So this is how we solve linear equations. So the combination of the two variables, you understand, you multiply it by their coefficient and you add or subtract them, should give you the constant that is on the right side of the equation. So if you have a question or any comments, or you want to add something to the flow, the floor is open. Let's make this interactive, please. If not, then we can move ahead and we looked at the, graphing linear equation. How do we graph linear equations? Actually, to graph linear equation is very simple. All you need to do is to find a way to know what is the y-intercept and the x-intercepts. Once you know these two things, then you can easily graph linear equations. So if you have any comment or a question, you can go ahead before we move on.
Yes,
Sir.
Okay.
Hello, sir.
Sorry?
Sir.
Yeah, you can go on, please.
yeah. The question I want to ask is,
Okay.
based on the linear equation, the x and the y.
Okay. The x and the y, I'm not getting you very well. The one asking the question. Your line is shaking or breaking. I'm not getting you very well.
What I want to say is, is the like the x and the y.
Okay.
Yeah, if the x is given to you, like for example, they say x is equals to 5. So it's normally occurs in question, right? Like what I mean, they normally give it.
X will not be given to you. You are the one who will assume. Okay, let's look at this. Like we have this equation 2x. We have, what's the equation again? 2x minus 3y, right? Equals to 7. If this equation is given to you and they said solve it, no one will give you, say that x equals to 2. No, you are going to assume that by yourself. You can take any real number. You understand? You can take any real number. You understand? So we have a number line here. So we have a number line, a real number from this goes here, positive infinity. Then it expands up to negative infinity. So we have 0 here. So you can take any number. When they said solve this equation, no one, I'm not going to give you that x equals to 2. You are going to assume what x will be.
All right.
Yeah. So it's for you to assume, before when I was solving, I said let x be 5. So when x, if I assume x is 5, now I want to know what y would be, the combination. So that number is for you to assume. You can take even 1 million if you want. But obviously, it's better you start with smaller numbers for to solve it. Okay. So you will assume. Of course, I can go forward. I want to make life difficult for the student. I said, let's x be 1 million. What will be the y? But if you don't have that scenario, it's for you to find the value of y. If x is not given to you by the lecturer, you can also assume any number. What you are looking is the key, the correct combination. I hope that answers your question. I hope this and the explanation answered your question. Okay, I think we lost the one who asked the question, but I assume it did. So if there is another question or comment, it doesn't have to be a question. You can also add 1 or 2 things. We are all coming from different walks of life with different experiences. So if you want to add another thing to what I have said, that class can benefit from it, you are highly welcome. Can we move on? There's other questions. Let's ask questions. Let's make this class interactive. Huh? Let's learn from each other.
Sir.
Yes?
Like if you assume x to be any number.
Yes.
And then you do the work in any answer you get, it's always the value of y in it.
Yeah. So you can, if you have, because if you know, in fact, one can even assume and say that if y equals to 2, then you find x is possible. Normally, in most textbooks, they start with x, but it's also possible to say y equals to 2. Let me find x. You know, but let's for this class, for consistency's sake, let's just always start with x. Let's x equals to this, then you find y to be more consistent.
All right.
So that's it. I jump the tradition. I didn't introduce myself from the onset because I feel like that there were many students that didn't logged in yet. So let's take this 5 minutes. We get to, I cannot, it will be hard for all of you, the 21 students, to tell you, but it's important to know your lecturer. So I will pause here before we move to the next graphs of linear equation, and we get to know each other, or you get to know me. I would love if it's a physical class whereby everyone can introduce themselves. But I have been with your university for almost 2 years now. I have been lecturing financial modeling. I'm Alfousseni Toure, by the way. I think you have seen it in the course outline. Some of you might have taken my course before, I'm not sure. So I'm Alfousseni Toure. I have been with CMIT for almost 2 years now, approximately 2 years. And I'm a part-time lecturer. So currently I work with Central Bank of the Gambia as a macroeconomist. Central Bank as a macroeconomist.
Okay.
At the Economic Research Department. So, but before Central Bank, I worked with other institutions. I worked with GAIPA as a project manager for 3 months, it's brief, GAIPA. I think we all know GAIPA. Then, but before GAIPA, I was with Access Bank Gambia, at their finance department, as I acted as an acting CFO for 8 months. But while I was there, when they hired me, my permanent position was deputy CFO. I spent 2 years, 4 months in this place. So I started with Access 2017. You know, so, but before 2017, I was doing my studies in Turkey. I did my BA there in Istanbul University in Turkey. I did my MA also in Turkey and my MBA as well. So my MA was in economics and master's in economics. I did master's in economics. MBA is more of a professional course, which was finance and accounting, the focus. It's master's in business administration, MBA, and accounting. So my undergraduate was in economics. So this is the background of your lecturer. I should start with this, but I felt like we had few students, you know, so I just started the class. So I said at some point in the lectures, I can give you a brief summary of the person you are dealing with. Since this is online lecture, some of us will never see me, but this is the brief background of your lecturer. So I'm with Central Bank as a macroeconomist in their economics research department. So this is the brief background, but you can call me Toure if you want. I don't have problem. You can call me Alfousseni. You can call me Mr. Toure. Doesn't matter. So as I said, this is mathematics. It's more about application than the mathematics. The prerequisite for this course, normally you should have taken the maths course, but from my experience, that's not always the case. Some people, the last time they have seen mathematics was in high school. So I have to do 2 things, trying to achieve 2 things at the same time, do mathematics, build that tool. Then from there, we can do application in social sciences. So let's move on to the how do we graph, unless you have a question, we can move to the other part of this. Sorry.
So I have another concept here. I don't know whether it's applicable on this.
Yeah, you can go on if it's related to the class. You can go on, please.
Yes. Like for instance, if you can say at y-intercept x equals to 0, or at x-intercept y equals to 0.
Okay.
Yes. I don't know whether that format is also applicable.
Yeah, it's applicable. This is what we will be doing. You use that when you are graphing linear equations. Yeah, the best way, there are many ways to graph linear equation, but I deliberately ignore it. Like, where is it? Like this one. Like, so this is y-intercept, not so. And we have x-intercept here. So I didn't deliberately, we haven't calculated it yet. So this x-intercept here, it's telling us that if y equals to 0, what will be the value of x? So y-intercept, what it means is this. If x equals to 0, what will be the value of y? So normally when it's come to graphing linear equation, these are the one of the techniques that we can use. But that's the next, what we will do next, that is graphing of linear equation, how to graph linear equation. So we will look at it, what you just said.
Okay.
Yeah. So let's move on, and we go to the fourth part of this lecture. That is graphs of linear equation, where we looked at intercepts. So all these things will come handy when we start to do analysis of demand and supply, or when we looked at determination of national income, something like that. So what we are doing now, we are honing our tools. We are honing the skill set, so that when we start the analysis of some of these problems that we have in economics or in business world, we can use this mathematical tool, how to graph it, intercepts, and something like that. So normally I should have started straight with demand and supply analysis, assuming that you have taken maths courses already. But people have different backgrounds, then it's better I do the maths part, then we can come and do the application in business and other social sciences. So how do we graph linear equations? That's how do we graph linear equation? So it's very, very simple. Sometimes you shall, let's say sketch. Let's say that sketch this linear equation. Sketch the line. So the line there is the same as equation, sketch the line, because linear equation is a line. Sketch the line. So 4x, let's say that this is given to us 4x plus 3y equals to 11. So when they say sketch this or graph this, graph the line or sketch the graph or sketch the linear equation, what they are trying to tell us, they want to see a graph. And first and foremost, when you are asked to graph a line or a linear equation, what you should focus on is what is the x-intercept? You understand? First, you ask yourself, what is the x-intercept? You calculate the x-intercept. We should find this first. And the other thing that we should find is what? Y-intercept. So these are the two intercepts we should calculate first in order to graph this line or linear equation. And what do we mean by x-intercept? When we said x-intercept, what we are asking, we want to know the value of x when y equals to 0 what will be the value of x. When we talk about y-intercept, is that we want to know the value of y when x equals to 0. So all what you will do, we said y equals to 0. If y equals to 0, what will be x? So if we looked at it, so what we will have is this. Here we have the equation, we make use of this. So we say that when y equals to 0, so here we remove this y and substitute it with 0. So I don't like to jump steps because people are having different background when it comes to maths. So we could have just calculated this and we will have an answer like 11/3. But let's do it step by step for the benefit of everyone. So we have 4x plus 3 times y, and we said y is what? 0. Then equals to what? 11. So obviously 3 times 0, this will be 0. So we have 4x plus 0 equals to 11. So obviously 0 will come here. You have 4x. So 0 will come here to be subtract, but at the end of the day, we'll still have 11. Remember, what we are interested in is what? X. Remember, we are asking what is x here. So to do that, we make x the subject of the formula by dividing both sides by 4. We have that. So by dividing both sides by 4. So we have 4x plus 3y equals to 11. So we substitute there. This is 0. This is 4x equals to 11. So that's it. Yeah. So at the end of the day, our x-intercept will be what? 11/4. Is there anyone who doesn't understand this? Or let me do the y-intercept. If you don't understand, we can go back and do it. So we have to also. Yes.
Yeah, this 11/4. Can you also put it in decimal format? That is like 2.75.
It's possible. So it depends on the choice of the person. You can express it as a fraction. You can express it as a decimal or even percentage. You understand? But yes, you will see that when I'm doing it in graph, I would prefer to put it in decimal. So that's where we will do it here in this space here. So this also, it could be expressed as a decimal. It depends on the choice of the person. Some people are, it's easier. But when it's come to graph, as you said, decimal is better to express it. And we will do it here once we start to do the graph. So at the end of the day, we will have something like 2.75. So we will have 2.75. That will be answer. But once we start graphing it, we will do it because most often the graph, the units of graph, they are in whole numbers or in decimal rather than fraction. I think fraction even confuse more people. Okay, so let's go to the y-intercepts, calculate the y-intercepts before we draw our graph. So we ask ourselves, if x equals to 0, what will be the value of y? So if you look at it, this is a point whereby the line crosses the x-intercept, x-axis, but we will see it with a visualization very soon. So we asked ourselves, so all what we need to do, wherever we see x in this line or in this linear equation, we substitute it by 0. So we will have 4x times 0 plus 3y, right, equals to 11. So this will obviously will be 0 plus 3y equals to 11. So at the end of the day, the goal is what? To find y, not 3y. So all what we need to do is to make sure that y stands alone. And how do we do that? Mathematically, we make y the subject of the formula by dividing it by 3. Obviously, this is gone, it's 0, it's nothing. So we divide it here by 3. So at the end of the day, y will be what? 11 over 3. So 11 over 3, if we express it in decimal, we are going to have something like 3.67. So we have 67. So now we have this, so this is the y-intercept. And what do we mean by y-intercept? This is the point whereby the line of the linear equation crosses the y-axis. So we can go on now and graph this with our coordinate system where we have the 4 quadrants. Yes. Yeah, I'm hearing you. You can go on, please.
We know the y equals to 3.67.
Yes.
You can also put it as y equals to 3.7.
3.7. Yeah, that depends on how, if the lecturer wants to make life difficult for you, you can say it, round it up to first decimal place. That's what you did, right?
Yeah.
Yeah, so it depends. You just follow the question. I can tell you, do it in fractions. I can even ask you to do the graph in fractions, which will make life more complicated for people. You understand? So I can ask you round your answer to 1 decimal place, which you just did. The first previous speaker talked about in decimal. You're talking about to round it in first decimal place. There are many, many ways to express the answers. That's also correct. That's true. So what I did here is just I rounded up to 2 decimal places. So if there is no instruction about what to do with the answer, then you go with your choice. The first one can go with the decimal. You can go with the first decimal place, rounding up the first decimal place. Someone can go up to 7. So it depends on your choice. But if I want a universal answer for that particular question, I can restrict you as well. Okay, let's now that we have our intercept, we have x-intercept, which is 11 over 4, or in decimal 2.75. We have y-intercept, which is 11 over 3, in decimal 3.67. Now we can comfortably go on and draw our graph. So obviously we have to do our graph on a plane. That is, we have put a coordinate, 4-quadrant coordinate system on a plane, that is white place, when I said plane. So this is a plane in mathematics. So we can go on and do that. We have this, and we have this. Obviously, our y-axis, this is y, not so. And then we have this x, so this quadrant here is where both y and x are positive. So here we have y positive, x negative. Here we have both of them as negative. Here, x positive, y negative. So what we will do here, this is telling us that the x-intercept, it's telling us that if x equals to 2.75, sorry, my writing is horrible. I'm trying to use the space. So y equals to what? 0. So you know that y here is what? It's 0. So, but x, let's even do our axis. The units depends on you, but I will take 1 unit. This is 1. This is 2. This is 3. I'm horrible when it's come to drawing graphs. So 5. Let's assume it's up to 5. So we have here 1. Here I have 2. So these things will come very handy when you are trying to demand the equilibrium price and quantity. When it's come to demand, you will use some of these techniques and tools and like that. So first we start with x-intercept. We said that if y equals to 0, here is 0, then x equals to what? 2.75. And 2.75 we assume is around here. We assume it's around here. So here will be the x-intercept.